Okay, hello everyone. Wow, this is like lots of people. I didn't expect that so many people are gonna show up after the party yesterday. And you know, like instead of all these like punchlines and whatever introductions, I want to say a couple of words about the community that I managed to meet, like people that I managed to meet like yesterday and the day before yesterday. It was so amazing. Like I'm really grateful to this community that it even just exists, and like thank you, like really thank you. So, you know what? Thank you, Mike. Oh, gosh. Thank you, Mike, for the intro. And, you know, this conference is also very special to me. Like, a couple of years ago, I was here and gave another talk. I think it was like network layer in React Native or something like this. And it's amazing to see how, like, conference grew over these 2 years. And so many things changed, and so did React Native, right? So we already heard like Emily's talk. It was like quite amazing about some highlights of the new things. And today I will try to do like my best to contribute like my 2 cents about React Native CodeGen and some other parts of the React Native architecture that I think are, like I personally think are important. But before I do that, one disclaimer, like even though, yes, I work at Facebook, but whatever I'm going to say now and today is not anyhow connected, and it's not representing any kind of opinions of Facebook whatsoever. All information for this talk was basically accumulated by GitHub issues and talking to relevant people. That's it. So, well, that said, I'd like to start this talk from, well, with a very, I'd say, maybe the most popular image and diagram like in React Native community. How many people know what it is and what I'm going to talk about for the next like couple of minutes? Any hands? No? 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 Oh, 1, 2, 3, 4. Hey, nice. Okay. Well, so this is basically the diagram of the way how React Native architecture works right now. It's a very like maybe rough idea, but like there are more details to this. But let's just talk a little bit about this. We have 2 realms, right? We have JavaScript realm, we have native realm. And there is something so-called bridge that is between them. So every single time when you try to call native API or render something from JavaScript in React Native, what is basically happening is that the message getting queued to the bridge, it's getting serialized and queued, and then at the moment when native thread has capacity to process it, basically dequeues this message, processes it, and if it's needed, it sends back the message exactly the same way. So what is noticeable here is that this architecture is asynchronous by design because of the way how bridge works. So bridge is asynchronous by design, and so is React Native, which is quite amazing in like plenty, well, I would even say like majority of cases. You don't really want to block anything. So that's nice. However, sometimes, just in some cases, you might actually need to have a capacity to use it synchronously. And the best way to explain this is to make an example. Let's say we develop an application, right? Like React Native application that has a huge list in it. And by default, React Native is going to virtualize this list for you. So what it basically means is that only elements that you see on the screen of your phone are going to be rendered. Everything outside of this is going to be probably just like some appropriately sized dummy components. There's just like blank rows or whatsoever. So this is quite nice, but there is one catch with all this. Imagine the case, you start scrolling this list, and you are on the low-end device. What is happening? OnScroll originates on the native side, then it needs new rows to be rendered, right? Because like viewport changes, so we need to render new rows. And it sends a message for every single row through the bridge to JavaScript. So it asks like JavaScript, hey, can you please render this element? Like tell me what I need to do. And JavaScript like, yeah, sure, fine. Here's what you need to do. And it queues it back through the bridge to the native side. So we do lots of things for every single row rendering, and we have like plenty of those. So at the moment when you start scrolling fast, you might experience something like blank row effect, or at least this is what I call it, like when you just scroll and you see like blank space instead of actual rows. And like this is basically because we cannot do the things synchronously. In the native world, this problem just like doesn't exist because you can recycle these rows in a synchronous fashion. So this is like quite great. What if we can do as a React Native developers or like community, how we can try to get closer to the native experience? So we can basically try to do better, and we can try to take some inspiration from other systems that already solved similar problems. For instance, we can like take browsers as an example. In browsers, this is already like fixed for us. We have JavaScript runtime, whatever you run there, and we also have some functionality. This is not a part of the language, however, it is exposed to us. For instance, set interval, set timeout, fetch, like whatever API you think of. Most likely, it is just a reference to the underlying C++ function that extends JavaScript runtime. So this is quite interesting. In order to do that, there is some native code that extends JavaScript engine runtime and basically proxies some native method to the JavaScript. And in this way, you can basically call the things from JavaScript directly. So you can call, you can call native code from JavaScript. But here is the thing. React Native might be a little bit different in this regard because if you think of it, we have two different platforms. Well, not even two, we have plenty of different platforms. And we might want to have like different JavaScript engines running, and even like across two platforms is like complicated to figure out the API and everything. But what if we have like plenty of platforms and JavaScript engines that we want to run with? So what if we can create an abstraction that will basically give us some kind of contract saying like, okay, you target this abstraction, and this abstraction takes care of like all this kind of magic, extending the JavaScript runtime on different JavaScript engines. And hopefully this thing kind of exists, and it's called GSI, but more about it like in a second. Sorry. Party yesterday was really good. Okay, so again, one more thing. What am I going to talk right now about? It's not yet in production. It's not ready and whatsoever. It's just a highlight. The entire purpose of this is to just shed some light on some architectural decisions and some insights of the new stuff. So that said, again, different JavaScript engines. We have our native code that we want to expose to JavaScript. We need an abstraction, right? And in this case, this abstraction would be GSI, or so-called JavaScript interface. And this is quite a fascinating part, because we as developers, we will need to write our native models in a way that it targets GSI. It targets GSI, and basically GSI will take care of the rest. But what does it even mean, like targets GSI or something like this? Maybe it's even wrong wording. You don't need to target anything. But GSI should know about your code, because your code is not just like, I mean, it doesn't exist standalone, fully standalone. It needs to be connected to the GSI. So there are so-called GSI bindings. And these bindings is something that basically knows how to call your underlying native implementation of the model. So at the moment when, like from JavaScript, you want to call something like your native model or whatsoever, it goes through the GSI. It go through these bindings, and in the binding there will be like this implementation detail. But anyway, there is a get method that basically knows how to call specific parts of your native model, and then it basically calls the native model, and the response goes back. So, what is another interesting part about the GSI? All the things you might imagine happens like in native, and it should happen like across different languages. So we need to run it like for Android, so it's going to be probably Java, and we also need to do something like in regard of Objective-C, Swift, and stuff like this. So we need a common denominator. What would it be? Most likely C++. But hey, we are not C++ developers, right? And it would be quite an experience to write GSI bindings for these kind of things. So another interesting part, before I go like to the entire solution, like what we should do and what we're probably going to do like in the future, let's just talk a tiny bit about this kind of architecture that we basically came up to. So we have JavaScript, right? It can call GSI or like directly. It can go through React Native. And then GSI basically knows about your native code and goes like through the native code. So there is one thing. Like, again, as I said, GSI, written in C++, bindings, also C++. We probably don't want to write those. Would be quite cool if we can, you know what it would be cool? Would be cool if we can generate these GSI bindings. But in order to do that, we would need to know something about the types. And hey, JavaScript is a dynamically typed language. We don't have any information about types before the runtime. And we actually want to have some. So that basically moves us to the point that we probably might consider using typed language, like, well, we can use Flow, or we can use TypeScript, or maybe something else. And then, before we run our application, we can run a tool like called CodeGen that's gonna take these types, parse all the things, and then generate some outcome. This outcome would be GSI bindings, as we talked about them just a minute ago. Then it's also going to be Objective-C protocol, abstract Java classes, or like whatever primitives it's going to be. And here is how it's going to help us. If we revisit our previous picture, then it will more or less resembling this. So we have TypeScript or Flow on our JavaScript side. Then we run CodeGen that generates a bunch of things, bunch of very handy things, like GSI bindings and some protocols and abstract classes for native implementations. And then we basically have this connection to the native code. But from the native code perspective, there is another cool thing. How we can make sure that whatever we have like in JavaScript and all these types and GSI bindings, how we make sure that our native implementation complies to all that. So this Objective-C protocol and abstract Java class, I put it not just for fun, but because this things really helps you, because you can like implement the protocol or inherit this class, and you will have a compile time type safety in your application. Because in this case, you're basically going to run your application. You're going to generate these things. And at the build time, we can know for sure if it's going to fail or not. So if it actually find this like contract between JavaScript side and the native side, or it's not. Which is bringing us to the concept of like the props that we're gonna have if we're gonna have it like in the future. So I already mentioned about compile time type safety. which is quite amazing. And I think, in my personal opinion, this is one of the best things that you can imagine with this piece of the architecture, because right now what we have, we might have different implementations on different platforms. We can have one method that accepts string on one platform and number on another platform, and JavaScript can send object. And there is no way how we can check this out before the actual runtime. So now we have absolutely no parity in terms of we don't know. We just don't know till we execute code. And this is something that's going to be fixed on a very fundamental level with the new architecture, and this is great. Another thing, you can imagine a save over the air updates. Probably some of you using code push, or at least know what it is. When you can push your JavaScript over there and update your JavaScript bundle during the, I don't know, development cycle of the application. What is cool about this is that, imagine this. You're updating your JavaScript bundle and you're changing the way how you work with the native API. And let's say, unintentionally, you have a breaking change. You don't know about that, but there is no way how you can check it out. Probably you didn't test this scenario or something, you don't know. But with this new architecture, what you can do, you can actually check your over-the-air updates for backward compatibility. So at the moment when React Native runs CodeGen, it also generates a so-called schema, which is basically a JSON representation of types and APIs of your component or turbo model or whatever it's going to be. So what you can do, you can basically div the schemas or write a tool that's going to make sure that the schemas are backward compatible. So at the moment when you introduce a new over-the-air update, there is no breaking changes. Another thing that is quite interesting for me personally is startup time. Because the way how it works right now, it basically at the moment when you start React Native, it should load all the models that it has, native models, because it goes over these models in order to generate JavaScript interface with these models. Because at the moment when you require native models from JavaScript, there should be something to require, right? And at the moment when you start React Native application, it goes over all this native models that you plugged into your system and tries to generate these interfaces for you, so you can just call it from the JavaScript. With the new architecture, we don't really need it, because we already have our JavaScript as a source of truth for all the things. So why would we? So we can generate it as a part of the CodeGen flow. So at the same time, we generate JSI bindings, we generate Objective-C protocol, we generate Java stuff, and we generate these so-called view configs, or probably native model configs as well. This is something that is still need to clarify. But anyway, this is more or less about the startup time. It's basically going to cut off this part. We don't really need to load everything in advance, and we don't really need to iterate over all the things and send it over the bridge and generate anything on JavaScript side. So that would be faster. And again, consistency. You have all the things, it should be consistent by design. Whatever you write your TypeScript, your Flow, or maybe even other languages. It will, using the CodeGen, it will generate you this contract between your JavaScript and native part. So that basically going to guarantee that your application will be way more resilient for the future. And yeah, that's basically, I think this is more or less it. Because I don't want to show any code and explain you schema, because these things are probably going to change over time before it's going to be released. But this concept, I personally think that that was quite fascinating in the very first place. But I also want myself and community to be a little bit prepared for things that are going to come, and I can't be more excited about this. This is just damn dope. Well, so that said, I think that's more or less about my talk, and I want to thank you for listening to me, and if you like this talk, please let me know. If you hate this talk, also please let me know, because I want to make it better and next time do it even more awesome for all you. Well, thank you.